Hi there, this is exercise 10. We've looking again now in a lot of detail at different types of functions we need to be able to differentiate. And this is the first one that we're looking at, which is the chain rule. And the chain rule is something which comes up again and again and again. So let's have a look at this chain rule. This is, of course, the rule that you've seen before. It's the rule that basically says to differentiate a function, x to the n, you bring the n to the front and you drop a power. So if I have y equals 6x to the 7 dy by the x, and it's called the gradient function, this. Sometimes written f dash x, you might remember seeing it written like that. But anyway, I do 7 6 to the 42, x to the power of, it was 7, so it becomes 6. So that's the basic rule. Not very good, 6. You get the idea. So if I'd come over to here, I can do this for all of these. Dy by the x equals, and just get into good habits, write dy by the x. 3 goes 6x squared minus 5 2 is a 10x to the 1, but I never write that. And 7x, you lose the x. And if there's no x at all, just ignore it. It disappears. Again, that's stuff you've seen before. Now, here, the very first thing I've got to do is multiply this out. So this is x squared, I reckon, plus 2x minus 8. And if it's in brackets, you're going to have to multiply it out. So when I differentiate, I get 2x plus 2. And this one, again, I've got to divide. So when I divide that, I get x. X cubed over x is x squared. Minus 2x over x is minus 2. And therefore, I can now find dy by the x. It's just 2x. And again, the 2 disappears. The number at the end just disappears. Now, not very nice powers, but it's the same idea on this. So dy by the x equals, well, bring the minus 2 to the front. There's effectively a times by 1. Knock off a power. And interestingly, it goes down, which is minus 3. A lot of people there would write minus 1. The same with this one. Minus something minus plus x. Knock it off a power. Minus 2. And the last one, quite simply, is dy by the x. Again, same idea, but now it's fractions. So it becomes half x. Knock off a power, makes it a minus a half. Plus 3 over 2, bring the power down, x. Knock off a power, this is like 1 1/2. Knock off 1 and you get a half. So that's my answers. Hopefully they say the same thing. I'll leave it to you to check. They seem right. So now the chain rule then. The chain rule allows us to differentiate composite functions such as these. Now a composite function is a function of a function. So this is a cubic function, but it just happens to have something in the middle of it. So this is like y equals x cubed. But instead of x cubed, I've got x squared minus 3 cubed. Here I've got a square root function. That's my function, but the function is the square root of another function. So that's why we call them composite functions. There are two methods, and on the face of it, they are very different. But one is the basis of the other. One's the formal proof, and the other is this. This is what we want to be able to do. But effectively, we're meant to be using this. This is the formal proof, and you can see here it says dy by the x is dy by du by the x. This is like a times. And you can see effectively the du's cancel. And therefore it's still dy by the x. But if you find it in u's, effectively, it makes it doable. This method is what we want to do. This is what Miss Frovine does. Or she talks about in terms of another way to look at it. You might want to look at that, but we're going to differentiate the outer function and then multiply by the derivative of the inner function. Let me show you that in action. So if I do this one here, it says use the chain rule. I think this is one we just had on the screen. I pretend this says x cubed. So normally I bring the 3 to the front and drop down a power. Notice I do 3 lots of x squared minus 3 and drop it down a power. And this is the bit that people forget. You then have to differentiate this middle bit. And if I differentiate that middle bit, I get 2x. So I now times by 2x. And my final answer is 6x, because the 3 lots of 2x. And because this has got squared, I either multiply out those brackets or I just leave it like that. I can't do anything else. This one. So again, I pretend it's x to the 5. It's something to the 5. So that would be 5. I don't know, I've done number 3 first. 5 lots of that bracket to the power 4. But now I have to differentiate this brackety thing. And you think about it, that is 1 plus 1 over x, which is the same as 1 plus x to the minus 1. So if I differentiate that, the number disappears. Who cares about that? The x to the minus 1 becomes minus 1x, knock off a power to the minus 2. Or if you prefer, just x to the minus 2 with a minus there. So I need to put the minus somewhere. I'm going to put it at the front. So it's not very nice, that. You know, it's minus 5 lots of that bracket to the 4, x to the minus 2. But that's the answer. This one again, just think to yourself what it means for a moment. It means 3x plus 4. And you should know that the square root is to the power half. So that's what y is. All this is, see, we haven't found what dy by the x is. Really, I should be writing this here, dy by the x equals. This is dy by the x equals. Bad. Not really, not to have done it. But here I remember, so that's a start. Dy by the x equals. Treat it like it's x to the half. Well, in which case it's half of something, rather than 3x plus 4. Now knock off half, knock off 1 from that and get minus a half. But don't forget to differentiate the bracket. And that's 3 when I get that. So my final answer here is 3 over 2. Lots of that bracket to the minus a half. And this one, again, it's not very nice writing like that. So I'm going to write it 2 lots of 1 plus 3x. And because it's on the bottom, all of that bracket is to the minus 1. And this now gives me the opportunity to find dy by the x. Well, it's got a 2 at the front, so it's still going to have that. I'll bring that power down and times it by the 2. Actually, that makes it minus 2. Minus 2 lots of the bracket to the power, knock 1 off there, that's minus 2. But now, times by the difference of the bracket, which is just 3. So I can write that as minus 6 lots of 1 plus 3x to the minus 2. Here's my answers. Hopefully, well, certainly the last one is. Oh, that's interesting. I wrote that one better. Minus 5. And then I did x to the minus 2. I just combined them there. I didn't like the way that was written. That's better. And these are fine. Yeah, they look fine. So some different types of functions. Now, you could use this when you differentiate exponentials. Essentially, you treat it in the same way. So here's 3 examples, and you'll notice is y equals 3 to the x, or rather e to the 3x. So when I differentiate, this is what I do. And well, you should know that if I have y equals e to the x, and I differentiate it, this is the beauty of e to the x, dy by the x is still e to the x. So here, really, all I'm doing is I'm saying, well, I know it's going to be e to the 3x, but now I've got to times it by the differential. And you'll see that the 3 just came down the front. I think we've seen those before. This one, first job, I suppose, is to write it as a negative power. And now it becomes easy. Notice the minus comes to the front, minus e. The power never changes on these. This is the great thing about exponentials. They're actually quite easy. Ooh, even this one, even this one's going to be the same idea. Oops, didn't want to do that. Even this one's going to give the same idea. So I know the power will stay the same. E to the x squared. E to the x squared. But notice now I have to times by the differential of x squared, which is 2x. So it's 2x e to the x squared. And that's what it says. Notice the indices never change. I've got a few more exponentials here, 4, 5, 6. So now if you get something like this is division. Much easier, just write it. Now division with powers, you should remember, become minuses. So this really is what I'm doing. And now I know that, I can just write dy by the x equals, notice, e to the 3x minus 2 will stay the same. But now I differentiate the 3x minus 2. 3. Next one. Dy by the x equals. Now can I rewrite it? Yes, I can. It's 3e minus 2x. The power is on the bottom, so I put it up the top, it becomes negative, and now I can differentiate it. So it becomes, well, bring the minus 2 down, that gives me minus 6 e to the minus 2x. Notice the power stayed the same, I just differentiated the minus 2x, and it gave me minus 2. Done. And this one, what's happening here? Well, the 3 is on the bottom, it's going to stay on the bottom. 2/3 e to the minus x cubed. Notice the only thing that changed here was the power became negative. The 2 and the 3 stayed the same. Okay, now I know that. dy by dx equals, well, I know 2/3 will be at the front. I know the power is going to stay the same. The only difference is I've got a times by whatever I get when I differentiate minus x cubed, which is minus 3x squared. Well, 3's cancel, so I reckon the answer is minus 2 x squared e to the minus x cubed. Let's see what the answers say. That looks right, that looks right, that looks right. Notice the indices never change on exponentials. On other things they do. So anyway, so now I'm going to look at logarithms and what we get when we differentiate logarithms. Now here's the rule. If you have a y equals log of some function, dy by dx is the function and whatever differential of that function goes on top of it. And we see the opposite of that in integration. So let's just work this out. So dy by dx of this one, remember what I said? It's a log, so it becomes 2x on the bottom. And then you just say, oh, what do I get if I differentiate the 2x? Oh, I get 2. Now, interestingly, they cancel. And I get 1 over x. What's the next one? It's a more complicated expression. It should perhaps be in a bracket like that. So technically, it becomes the bottom of this fraction, x minus 1 over 3. And then to the top I differentiate now. Divided by 3, well, let's just write x minus 1, all divided by 3, and that's the same as x over 3 minus a third. So if I differentiate this thing to get the top thing, because that's what that says, then all I'll get, that number disappears, and all I get is a third. So it's 1/3 divided by x minus 1/3. And they effectively cancel out, and you end up with 1 over x minus 1. Notice, having the divided by 3 didn't really make any difference. Notice having the 2 didn't really make any difference. So, I suppose the only thing that mattered here was it was minus 1. That stayed. Log of x cubed, so same idea. I think this one's easier actually. Put x cubed on the bottom. Differentiate it, 3x squared. Interestingly, that counts as that. Well, at least some of them. And I end up with 3 with 1 more x on the bottom. That's my final answer. Next one. Now, it's the log of all of this. So I suppose it's probably worth my while to write this as the log of, well, it's the difference of 2 squared, actually. I can just do it quickly. I reckon you do it, you'll get 1 minus x squared. So this will just be divided by dx equals, well, on the bottom I'll put 1 minus x squared, on the top minus 2x. I don't think I can do much more with that. And on this one, well, I've got to put, it doesn't look so nice, does it? And what I would suggest we should do is, because I don't like it much, I'm going to rewrite this. This one I could have done a similar trick, but I didn't need to. But this one's really like, logarithms are funny things. When you do divisions, they really can be written as minuses. So this now becomes just a simple set case of saying, well, let's do the 2 bits separately. And I've got log of that, so put it on the bottom, 1 plus 2x. And on the top is the differential of that, which is 2, minus, this is a log again, so it's a fraction, put that on the bottom. Differential of minus 1 minus 2x is minus 2. Ah, that makes that a plus 2. And that's what I think the answer is. Yeah, I do get a plus. Now, I think there's more on this PowerPoint, but that's as much as I'm going to get through today. So what this is leading to, yeah, there's trig functions, which I haven't yet done, and then exercise 10A is what we'll do in class. But we can start next lesson with the trig functions. So best of luck.